Caution, it says verifying identities is not the same as solving equations. For years, we've had equations like this, and we've always said, well, let's just divide both sides by 4. It's going to be very tempting for you to try to do that, but you're not going to be allowed to do that. Consider this. If I had square plus triangle equals 10, right? You have no way of knowing if that equation is actually a true statement or not, okay? Always before, when we had regular algebra equations, we know that's true. 4x equals 12 was given to us, and we took that and understood that it was a fact, and that's true. Okay? But here, in these problems, when we are verifying, we don't really know. That's a question mark. We don't really know if square plus triangle equals 10. We're trying to prove that that's the case. And so you're going to be tempted at times to subtract triangle or something from both sides. You're going to be tempted to subtract something from both sides, or divide both sides by 2, or square root both sides. We're not allowed to do any of that because we don't know for sure if this is an actual identity or not. Okay? That's what we're trying to prove. And so it says a lot of the times we're going to verify identities by working on one side. What that means is you're going to pick whichever side you think looks more complicated and try and simplify it, try and clean it up, try and combine like terms, use an identity, use some algebra, and try and clean it up, but you're trying to make it look like the other side. Our main goal is to make sure that the left side of this equals the right side of this, okay? And it doesn't matter if you work on one side or work on both sides. What matters is you prove that the left side equals the right side. So let's look at an example. Example 1, verify cotangent theta plus 1 equals cosecant theta times the quantity cosine theta plus sine theta is an identity. Okay, so at this point, we do not know, I know it says equals, but we don't know if that's actually equals or not. That's what we're trying to prove. Okay? So one of your hints says start on the more complicated looking side. More complicated looking side looks like the right side to me. So you want to look at the right side and you want to do something to the right side. Okay? But one of the very most common hints and tricks that you can use is to change things in sine and cosine. You'll use that all the time. And so this cosecant theta right here, cosecant theta, I know how to change that into sine and cosine. That's one of the fundamental identities. Cosecant theta is 1 over sine theta. So cosecant theta is 1 over sine theta. Let's just leave the rest alone. I'm going to try really hard to line everything up. Okay? I'm going to try and keep that right side underneath my right side of my equation. But I've got 1 over sine theta equals the quantity cosine theta plus sine theta. Usually what happens is after you use one of the identities, you'll be able to do something algebraically, and something's going to cancel out or clean up in some way. And so you might be thinking, well, what if we distributed that? Okay? We're allowed to do that. Distributive property would give me cosine theta over sine theta plus sine theta over sine theta. And the very best of you are going to be able to look at that, and you're going to be able to plan ahead. Because remember, one of the hints said to keep an eye on the other side. Because that's our goal. That's what we're shooting for. Whatever we're working on over on the right, we want to try and make it look like what this is on the left side. We want to prove that the left side equals the right side. And so the very best of you can probably see how it's going to work. Okay? Usually something's going to cancel. We're going to use an identity, something's going to cancel. And so I see right here, cosine theta over sine theta. I know what that is. That's one of my identities. That's one of my fundamental identities. I know that is cotangent theta. And that's good because I want cotangent theta. Okay? Plus, if you know that sine theta over sine theta is going to cancel out and be 1. And so I have exactly what I need. I have my right side equal to my left side. And as soon as you get that, as soon as you get left side equals right side, you're finished. Okay? And you don't have to write LS equals RS, but that's what you're looking for. Okay? When you're finished, you're going to write QED. Okay? QED is a Latin acronym Quod erat demonstrandum. And you're probably going to recognize one of those words, even though you don't speak Latin. You're probably going to recognize one of those words has something to do with the word demonstrate. Okay? I was asked to prove or verify that that equation was an identity, and I just did that. I just demonstrated what I was supposed to do. So do not circle QED, because QED is not your answer. QED is like the period at the end of your sentence. Okay? This is a proof, and so the entire thing is your answer. QED is just how you show you finished. And you did what they asked you to do.